Today we're going to look at this question. Draw the structures of each pair of amino acids and indicate what types of intermolecular forces are present between the side chains. So first off, you're going to need to know how to draw each amino acid, and you're also going to need to know their three-letter code. So TYR is tyrosine, THR is threonine, LEU is leucine, and VAL is valine. Okay, so drawing the structures, I draw my structures in a particular way, especially in a question like this. I tend to draw the R groups first and close to each other and work my way back, just for the sake of complication. So tyrosine has a benzene with a hydroxide group on the end of the benzene structure. So that's how I draw tyrosine. Okay, from the beta carbon, I work my way back from the R group to the beta carbon to the alpha carbon. Okay, this is tyrosine. You have your alpha carbon, which should have a hydrogen here, your alpha carbon, your beta carbon, your benzene structure with your hydroxide group on the end. And then next to it, I'm going to draw threonine. Threonine, the beta carbon actually splits into a methyl group and a hydroxide group. Then the alpha carbon, where you're going to find the amine group, and the carboxylic acid group. So there is threonine. Okay, so looking at this is the point of interaction that we're focusing on. What type of interaction is this going to be? Or what type of intermolecular force is the question asking? And when I see this oxygen and this hydrogen interacting with each other, the first intermolecular force that I'm thinking of is hydrogen bonding. This one is hydrogen bonding. Okay, and there's three types of intermolecular forces you need to know. You have hydrogen bonding, dipole-dipole, and you also have London dispersion van der Waals forces. So the three types are dipole, dipole-dipole is if you have a partial positive close to a partial negative, and this could be any type of atom, not just hydrogen and oxygen. And when these types of atoms get close together, they cause an intermolecular force that brings them closer together. Hydrogen bonding is a type of dipole-dipole bonding. Only hydrogen bonding is specific with, of course, hydrogen, but also it's going to be, you're going to have oxygen, nitrogen, and fluorine. So hydrogen bonding is specific type of dipole-dipole bond between hydrogen and oxygen, hydrogen and nitrogen, or hydrogen and fluorine. So that answers question A. Question B, we're going to look at next. You have leucine. So I'm going to do the same thing. I'm going to start from the end and work my way back on the R group. Okay, so, gotta put this hydrogen here. So leucine has this long chain of carbons with an extra beta carbon, compared to valine, which has somewhat the same structure but has one less carbon than leucine. This one is leucine, and this one is valine. And the type of intermolecular force that we're looking at is right here. Okay, and that is the one that we haven't written out yet. So this is going to be London dispersion, or van der Waals forces, or van der Waals forces. Those are your three types of intermolecular forces. This one, B, is going to be London dispersion, is when you have nonpolar molecules being forced close to each other. So what you see is these long chains of carbons being forced together because they're nonpolar, and that's the intermolecular force that causes London dispersion, or van der Waals forces. So that's it for this question. Thank you for watching. If you have any questions, leave them in the comments below, and I'll see you all in the next video.